Hi, so today we're going to create an OpenEEW, which is to say an earthquake early warning system, in 3 very simple steps. Step 1, we're going to set up our MQTT broker. This is the broker, the message service, which allows the sensor to send data frequently to the detection system. So in my case, I've got Ubuntu running. This could be done on Windows or Linux, another Linux or Mac. I'll have information below as to what you would do for the different operating systems, but in this case it's just one line and it's installed. In case I want to check if it's actually running, I'm just going to look at its status and it's running, so that's great news. So step 2, we're going to flash our sensors. For this we're going to use Visual Studio Code. In Visual Studio Code, we're going to navigate to the repo that we've just cloned from OpenEEW, which is the firmware. And in the firmware, we're going to make sure that we can see everything here in the Explorer. All of the files should look exactly the same as I've got them here. Before we go any further, we need to install the extension, which is Platform.io. So in the Extensions tab, we're just going to look for it, Platform.io. And it comes up and we're going to install it. So now that it's installed, we go back to our Explorer window. We can see all of the files, and the very first one we're going to open is the INI file in the root directory. Here we just need to tell the device, or rather we need to tell Visual Studio Code which port it's going to flash the code to. So in this case we're using Ubuntu, which means that we're using this address for USB. If you're using Windows, it can usually do it automatically, so I would just comment it out like that. But as I said, in Ubuntu this works fine, so we can close. The next thing we're going to do is go into our secrets.h file, and here we need to just add a few bits of information. First of all, we need to tell it where is the Mosquito MQTT broker that we just installed. So here I'm adding the address on my local network. And then you're going to have to give it the port number, which is almost always 1883. If in fact you've gone a little bit further and you've installed a secure version, then you're going to want to use whatever port number you've used there, but this will work fine out of the box. For the actual station, which is to say the sensor, we're going to give it some information. We're going to give it a username. This isn't important, but if you had multiple networks, you might care about this. We're going to give it a network name, which is a 2-letter standard seismological convention. In this case, GR for Grillo. It doesn't really matter what you choose to use. And then we're going to give it a unique 5-digit identifier for this sensor. So in this case, GR001. We are now good to go. We're going to close that. The only other thing you might want to check is that you've installed drivers so that your sensor can communicate by USB. I'm going to add a link below. In Linux this is usually just fine automatically. If you're using Windows, there's a couple of links you might want to check out to make sure you can connect. So now that we've done this, let's have a look at the sensor. So this is going to be our sensor GR001 that we've just labeled. We're going to connect it by USB. Inside we have a typical OpenEEW sensor, and we're ready to go. So in Visual Studio Code there's a little icon right on the bottom in the blue bar which says upload. This is going to compile the firmware and send it by USB to the device. Okay, and it's writing straight away, so that worked very well. Perfect. These devices have a little ESP32 microcontroller, an ADXL355 accelerometer, Ethernet, LEDs, and a little buzzer. So we can use the little icon here at the bottom, also in the blue bar, called Serial Monitor. In this case I'm going to just tell it to look in the 3rd option, which is the port of this device. And straight away we're listening to the device's printouts. It's telling us that it's waiting for smart config. that means it can't connect to the Wi-Fi. So we're using a protocol on the phone to connect it. If you have Ethernet plugged in, it won't do this. It'll just go straight to sending the messages by MQTT. But in this case, we haven't connected Ethernet. So we're going to now open up our Android device, could be iOS, and we're going to look for an installed. We're going to install, if we haven't already, ESP Touch. So first of all, you're going to want to make sure that you're connected to Wi-Fi, which this phone is, and you're going to want to make sure that the Wi-Fi is a 2.4 gigahertz network, which this is connected to. We're going to go for the original ESP Touch version 1. I'm going to make sure that I say yes, you can use the location of the device, otherwise it doesn't work. Here we've got the OpenEEW network. I'm going to add in the network name, which is in this case OpenEEW 2022, and that's all you need to do. So everything is ready. So once we confirm, you will see in the serial monitor it will eventually perfect. So using the app, we've managed to send Wi-Fi details to the sensor, and the sensor is now working. So now we can see that it's starting to read the FIFO on its accelerometer, which means it's grabbing batches of accelerations every second, and it's just going through these to make sure that it understands if there's any noise, it will average out the noise, so we just get a clean signal offset in every reading. And it's now ready to go. So it's recognized the sample rate. It's sending packets every second, which include the network, the station, the time, which is very accurate on this firmware, and it's working. So now it's sending it to the MQTT broker. What we're going to do now is we're going to also very quickly create a second sensor, which is in this case going to be GR002. So if I go to secrets, the only thing I need to change now is the station name, GR002. And I'm going to flash this new device. Good, well, it seems to have worked. So again, there's a little serial monitor icon down here. I'm just going to select the third option, which is the port I need for my sensor. And again, this one needs smart config. So one more time, I'm going to go back to my Android screen. I'm going to open up the app. I'm going to make sure I've got the password I need. I'm going to confirm, and the device will receive and quickly connect to the router. Done. So we now have two devices, each with unique sensor station names, sensor names, and they're sending data to the MQTT broker in real time, once every second. Okay, and now for the third part of the video, we're going to create the earthquake detection system. So as before, we're going to open up VS Code, but this time we're not going to use Platform IO. We're just going to navigate to the repository that we've just cloned, which is the seismology repository. And inside, you're going to find these files. So the very first thing we need to do is go to our config, and we just want to make sure at the very top that we have the path correct. So this path is going to be the path where our XML file is. The XML file will describe what the sensors are, where they are. So in this case, we just have a testing folder. I've created a GR for the network GR, and here is the GR network XML file. So if we were to go into our GR XML file, which is in testing, here we go. What you're going to see here, this is a typical seismological convention for an index file for your sensors. What we're going to see is that we have the network, which in this case is GR, and for every station we're going to have some information. So for GR001, we explain where it is in terms of latitude, longitude, and then we're going to repeat that for each of the channels. Each of the channels just means X, Y, and Z. So all you need to do is repeat the information for X, repeat the information for Y, and so for each of your devices we're going to need a different station, which is effectively this. That is one station, so just copy and paste for as many devices as you have. This is GR001. As you can see, the next one is 002 with a slightly different latitude and longitude, or rather it should be anyway. So once we've done that, you will have your complete XML file. So we know the detection system knows where the sensors are located. And in the terminal, you're going to want to add in your requirements. So pip install our requirements.txt requirements.txt, and I've already installed them all. It actually takes a bit of time. There's quite a few dependencies, but you should get to this. So now we're pretty much ready. The only thing that's missing is in the secrets YAML to add in the information for MQTT. So remember, once again, you're going to add in the address as before, you're going to add in the port number as before, and you are good to go. So now, if we were to start our detection system, we would be just typing python 3 main.py, and we have an earthquake early warning system. If I was to show you now the two sensors that we've just flashed, here they are. So right now the system is listening to all the messages. If I was to move two of them, we've got detections and now we've got an earthquake because they're moving at the same time in quite a sort of rapid motion. Remember, this is just I've just got two devices. Normally you would ask for 3 devices to trigger it, and we have an earthquake in progress. In case you did want to have more than just 2 devices, you would need to modify the config file, and in the config file further down here, I believe it's number line 35. You would just change this value. So normally you would have this about 4. It depends on the density of your network, but for this demo I created it 2, and that is an STA LTA trigger, and then we associated both of those triggers due to the distance, which were very close to each other, and an earthquake was considered.